Hi everyone. We're going to look at slope of lines today, and I want you to get yourselves all reacquainted with this. Definition of the slope of a line: the vertical change over the corresponding horizontal change. You might have heard rise for vertical over run for horizontal. So how much does a line change vertically as it goes over to the right horizontally? Through 2 points, we have m, which is the variable for the slope, is equal to y2 minus y1 over x2 minus x1. Now, example 1. Find the slope of the line graph below. Let's just look at the graph. I see a point right here and a point right here, and I'm going to talk about the rise. 1, 2, 3, 4, 5 units. It goes 5 units, and then run 1, 2 units. The rise of 5, a run of 2. That's if you're looking at it graphically, the rise over the run. For every 5 units it goes up, it goes 2 units to the right. That is a positive slope. Now example 2. Find the slope of the line that passes through -2, 4 and 1, 2. This time I want to use the formula. I'm going to take y2, 2, minus y1, 4. 2 minus 4 over 1, which is x2, minus x1. 2 minus 4 is -2. 1 minus -2 is 1 plus 2, which is 3. So the slope there is -2/3. Now if I look at where -2, 4, -2, 1, 2, 3, 4 is, right here, and 1, 2, 1, 2, that one right there, if I look at that line right here, you notice that slant? Notice this sign is negative. If it slants from left to right upwards, we've got positive slope. If it slants left to right downward, we have a negative slope. Now let's look at example 3. Find the slope of the line that passes through -2, 7 and 3, 7. Well, let's use the slope formula again. Let's take y2, 7, minus y1, 7, over x2, 3, minus x1, -2. 7 minus 7 is 0. 3 minus -2 is 3 plus 2, which is 5. That slope is 0. Now let's think for a moment. -2, let's put 7 right there. -2, 7, 1, 2, 3, 7 is right here. So we're talking about this line right here, and that 0 slope goes with a horizontal line. Example 4. Find the slope of the line graphed below. Well, the rise, it's got all sorts of rise, 1, 2, 3 units. The run, it does not go left or right. The rise is 3, the run is 0. That is undefined. You are not going to calculate that one very easily. If you take 3 divided by 0, divide by 0. It says don't do it. Don't do it. It's undefined. And vertical lines, like the one you see right there, have undefined slopes. So I do want you to associate, if you haven't already, positive slope slants up from left to right, negative slope slants down from left to right, 0 slope is a horizontal line, undefined slope is a vertical line. If I graph the line that passes through -2, 7 and has a slope of -5 halves, what I want to do, I want to find the line it passes through, the point it passes through. -2, 1, 2, 3, 4, 5, 6, 7 is right here. Down 5, right 2. 1, 2, 3, 4, 5, right 1, 2, right here. Let's do it one more time. 1, 2, 3, 4, 5, down 1, 2. I kind of left my grid there. That is all right. But I'm graphing that line like so. There is the line that goes through that point and has that slope. The next thing I want to talk about is parallel lines. Parallel lines have equal slopes. If I were to put a point right here, and if I were to go down 1, 2, 3, 4, 5, and over 1, 2, that same slope, what you're seeing there is those lines are parallel. Now, perpendicular lines, what should be said about that is if M1 is the slope of one line and M2 is the slope of another line, and M1 times M2 equals -1, then the lines are perpendicular. Remember that symbol, upside down T thing for perpendicular? Okay, and a lot of times you might remember that the slopes of perpendicular lines are opposite reciprocals. Opposite reciprocals. Okay, example 6 here. Graph a line that is parallel to a line with slope of m equals 1/4 and passes through 0, -2. Okay, the line I want passes through 0, -2. It's parallel to a line that has a slope of 1/4, so it has a slope of 1/4. I'm going to go up 1 and over 1, 2, 3, 4. I'm going to go down 1 and left 1, 2, 3, 4 just to get another point on there. Makes it nice. 2 points is plenty. 3 points just kind of confirms that you're in the right direction. And as I look, I've got this line right here. So I've done what example 6 asked me to do. That's the line. Now the next one, graph the line on the grid above, this one, that passes through 2, 3 and is perpendicular to the first line. Passes through 2, 3. 1, 2, 1, 2, 3. Alright, well the slope of this one, to be perpendicular, has to be the opposite reciprocal, -4 over 1. 1/4 times -4 over 1 equals -4 over 4, which equals -1. Okay? So if M1 and M1 times M2 equals -1, then the lines are perpendicular. Okay, this opposite reciprocal will make what we need to get -1. So let me go down 1 unit. No, let's go down 4 units. 1, 2, 3, 4, and right 1 unit. And don't do that. Let's go down 4 units and left 1 unit. I'll do it again. 1, 2, 3, 4, 1, just to make a nice purty line. And boom. Okay. Now, do you notice, does it appear that these two lines, down 1, 2, 3, 4 over 1, up 1 over 1, 2, 3, 4, are perpendicular. They're making a 90-degree angle. Solve for R in this one. The slope through 6, and R is the y-coordinate, and 9, 2 is 1/3. Okay, the slope, remember, was y2 minus y1 over x2 minus x1. Well, if I translate that over here, the slope is 1/3. That's the M. y2, I'm going to use 2. y1, I'm going to use r. That's an r. x2, 9. And 6. So, let's simplify what I can. 1 over 3 equals 2 minus r over 3. Ooh, nice. I've got 3's on the bottom. Those are the same. I could multiply everything by 3, and if I do, I got 1 equals 2 minus r. I'm going to subtract 2 from both sides. I got negative 1 here. Those cancel. Negative r. So I'm saying r is 1. So 6, 1 and 9, 2 have a slope of 1/3. Just some practice for you to try. Thank you. Enjoy your weekend and do that worksheet.